We're continuing on with equations, and now we're going to take a look at what happens if I have like terms on one side of the equation. These rules, get x by itself is your goal, do the opposite to whatever's attached with some really good OCD-like neatness. They never change. Those rules are always there when solving equations. So now if I look at problem number 1, my goal is to get x by itself, but notice that x is happening in that term and that term. We haven't had that in any of the introductory equations we've had. Well, we've learned to put together like terms, so here we go. I underline the terms that are like terms because they have the same variable and the same exponent. There's an exponent of 1 even though we don't bother to write it. A positive 4, remember if you don't see a sign, it's positive. A positive 4 and a negative 7 combine to give me a negative 3x. So now I have negative 3x minus 8. I didn't do anything with that minus 8, so I just recopy it, equals 12. By putting those two like terms together, I've made a more simple equation for myself. In fact, this is just your standard two-step equation. I'm going to go ahead and solve it rather quickly. I move the 8 over, so now I have a negative 3x equals 20. I divide each side by negative 3. And in this case, 20 divided by negative 3 doesn't happen evenly. So I could rewrite it like that, or I could call it negative 6 2/3. Either one of those would be okay. Let's look at number 2. I've got an x here and an x here. If my goal is to get x by itself, I can't really have two x's floating around. I notice some distribution, so I'm going to take advantage of that. Negative 3x plus 18, be careful with your sign. So after that distribution, I see that this is a like term with this. They have the same variable and they have the same exponent, which is 1. So I combine those and I get a 2x. Remember, I haven't touched the 18, so I leave it. And now I have a much easier equation. Let's move the 18 to the other side. It's a plus 18, so I do minus. Now I get 2x equals a 10 combined with a negative 18 is a negative 8. X is not by itself yet because the 2 is attached by multiplication, so I do division to each side, and I get x equals negative 4. Kaboom, I'm done. All right, we're going to do one more of these. I'm going to look at this one down here, and right away I see some like terms, but you'll notice I put an asterisk by this because there's going to be something goofy that happens here. Well, let's combine these two. A negative 4x and a positive 3x combine to give a negative 1x. So I have an 8 minus 1x. Remember, when there's a 1, you don't have to write it as a coefficient, equals 18. My goal is to get x by itself, which means I need to get rid of that 8. I must remember that that's a positive 8. So I subtract 8, subtract 8. Now here's why I put an asterisk by this. That negative sign or that subtraction sign on the x has to stay. 18 minus 8 is 10. All right, so here's the dilemma. When you solve an equation, your goal is to get x by itself. At this stage, x is not by itself, it's a negative x. So what you can do is flip the sign on that side, and then because everything in an equation has to be fair, you have to flip the sign on the other side. So anytime you finish with a negative x, flip the sign, and flip the sign on the other side. That is equations with like terms on one side.